Okay, this is Algebra 1, Semester 2, Unit 7, and this happens to be Section 11.2 of Unit 7, Algebra 1, Semester 2. Okay? Here we go. We are working with radicals still. So, when you see that you've got two radicals being multiplied together, I don't increase them by their product. Instead, I break them down. 2 times 3. And 8 would be 2 times 2 times 2 if you've memorized it in your cubes. Now I go ahead and I write all their factors under one big prison, which is how we look at those radicals. Now we know that it takes 2 to get 1 out, so we trade in those 2 to get 1 free. Trade in those 2 to get 1 free. And 3 doesn't have a partner, so he has to stay in prison. 2 times 2 is 4. 4 root 3 is our answer. Next one. See how the 6 is already outside? We leave it outside. 5 doesn't break down. 7 doesn't break down, so we just go ahead and multiply those on the inside of prison. So it's 6 root 35. On this one, everything's inside a prison, so we'll build one big prison. We have 3 x's there, 5 x's there. These two can get free for 1. Those are free for 1. Those are free for 1. And those are free for 1. Everybody gets out of prison. So we end up with x to the 4th. On this particular problem, x is already out of prison, so we leave him free of the prison. We have a 2. 8, if you've memorized it, breaks down to 2 times 2 times 2. That's equal to the 8. Now we can get those 2 out. We can get those 2 out. We already have x out, so that becomes 4x. Here, let's look at what we've got inside prison. 4 breaks down to 2 and 2. 5 breaks down to 5 and 5. And then we've got an x, and we have 3 more x's. Oops, I almost got too many. Okay, these 2's can get out. These 5's can get out. Those x's get out. And those x's get out. Nobody's left in prison. Well, we need to clean this up a little bit. 2 times 5 is 10. X times x is x squared. Okay. Again, make sure to pause the video, rewind, watch the explanation over and over, as much as you need to. Again, on this, I would break it down. I would do radical 49 over radical 16. And then I'd go ahead and break those down. 49 is 7 times 7. 16 is 4 times 4. And those get out. And those get out. Here we have radical 8 over radical 9. That would be radical 2 times 2 times 2 over radical 3 times 3. The 3's get out. 2 of the 2's get out. Now remember, they only become 1 on the outside, but 1 2 stays in. So that's my final answer. Okay. Next one. I would be reluctant to divide this down into this, and here's why. Because I can't get rid of that 5 on the bottom, and you can never have a radical on the bottom of a fraction as your answer. So I would reduce it in this form first. 5 goes into 20, radical 4 times. Okay, and the square root of 4 is 2. Our tape is going to run out on this showing, so when it does, then just finish the rest of them on your own, and you can check them in class with me. So 50 over 40, I would reduce that by 10 on the top and on the bottom. And so you would end up with radical 5 over radical 4. Square root of 4 is 2. And leave the radical 5 on top. You can always have a radical in the numerator. 20 and 18, I'd divide them both by 2. And I'd get 9 and 10, still under the radical. Radical 9 is equal to 3. Radical 10, it can't reduce because it's 2 times 5, so that is our answer. On this one, 4 goes into 12 3 times. So we would have 3x cubed over x squared. Now again, I'd reduce the x squared and the x cubed. There would be 1x left up there. So it's radical 3x. Okay. Simplify quotients. We can't do anything with this. It's a problem. We can't have a radical on the bottom. The only way to get rid of that radical is if we have a prisoner of the same amount. If we multiply a fraction by the same thing top and bottom, then it's equal to 1 and we haven't changed its value. So this becomes radical 9 and radical 6. Radical 9 is equal to 3 and we can leave the radical 6 on top. That eliminated our problem right there. So that's called rationalizing the denominator. Anytime you have a radical on the bottom, multiply by itself to get rid of that. Okay, give you a couple answers here. So this becomes radical 60 over 5. Now 60 might break down. We know that it was 12 and 5, 4 and 3, 2 and 2. So we have 2 times 2 times 3 times 5. The 2's can come out, so we'd have 2 radical 15 over 5. You cannot reduce inside and outside of those prison walls. So you have to leave it that as the lowest form. On this one, I would go ahead and take the 8 into 16 and just get radical 2 as my final answer. Radical 3 over radical 24. I would reduce that. 3 will go into both. So I would reduce that to 1/8. Then I'd take 8 and I'd break it down to being radical 2 times 2 times 2. 2 of those 2's come out, so I would have 1 over, because radical 1 is 1,